Learners, in this program, the focus is on the recent developments which have taken place towards early warning of natural disasters, our understanding in the polar and climate change science, ocean mineral exploration, and how these developments are beneficial to the society.
Thank you very much and hello friends. Natural hazard is another major area which affects the society, either cyclone or a tsunami or a sea level rise, and this I will show you some of the examples. Of course, the last 2 years everybody is aware of the Pilin cyclone, and then last year the Hudhud cyclone have been predicted very well. Even some of the international agencies were saying that what our predictions are not right, but we stick to our predictions and showed that our predictions are pretty accurate. This happened because of the two things. One, we have a very heavy investment done on the ocean observations. Because the cyclone originates from the ocean, so we need to know what is happening on the ocean. The satellite gives you what happens on the surface of the ocean, but our buoys which we installed give you the subsurface information, and this tells us that whether cyclone is likely to come or not. So now we know at least 10 to 12 days before whether cyclone is going to originate or not. And this, using the certain models, the track is predicted. And when you predict the track, these buoys also provide the information whether your predictions are right or wrong. So every day there is a chance for us to monitor the progress of the cyclone with service the ocean observations and then improve upon it if there is any likely change. Now this is very critical because if you can predict accurately and the effect of those cyclone, you can evacuate only those people. So large amount of the expenses can be saved. It is not just evacuation, you also have to provide them shelter, water, food for 3, 4, 5 days. So if you can as accurate as you give, that means that many less number of people are evacuated and it saves. So this has been done very accurately, but the actual damage and loss of lives has nothing to do with the prediction of the track. It is more to do with the kind of waves which are generated into the sea. So this is what also we give the prediction of the waves, and you can see in the graph that the prediction and actual there is a close similarity. Also the surge, that means along with the cyclone the sea water goes into land. This is what we call as a surge, and this surge also has been very well predicted, and also at a local level, each mandal level or taluka level, how much height is likely to come is given, and what will be is inundation, that it will go to 100 meter, 200 meter, 300 meter. After the tsunami, this system came in 2007, and this is the major change which has occurred on the knowledge existing at that time. We evolved a system where we are giving a location specific warning of the run up height as well as the travel time on 1800 coastal forecast points for all along the Indian Ocean. And this is the only system which gives you the information for entire Indian Ocean and from the two tsunamigenic sources, Andaman, Nicobar and Java, Sumatra subduction zone and Makran coast in the Pakistan. This is the example of the earthquake which took place in Pakistan, which created a landslide into the sea, and our sensors picked up this tsunami very well. Tsunami did came, but very low, about 55 centimeter in Oman, and this was recorded and predicted extremely well. People always ask a question that why you are unable to predict the earthquake. So before I go to that, the two things we are trying to do, one is there are precursors to an earthquake. Many people have observed that the radon gas emission or groundwater level, or there are changes in the microgravity and many such things. Now, this we have put two laboratories, one in the Uttaranchal in Guttu and one in Shillong, to find out all such precursors which takes place and see that whether they are correlate to any earthquake. The second is you find out in a city which are more vulnerable areas for the earthquake and give this information to master planner or urban planner so that the buildings which you construct are earthquake resistant. So, these two are being done. Now, why we are unable to predict earthquake? The reason is that the earthquake takes place very below into the solid earth and you are not observing them. What you are doing is measuring from various seismic stations or accelerometers that from the ground. So, the signal is coming through variety of strata and the signal is not very pure. So, you can't make very accurate judgment on this. So, we have now taken up a major program in Koina where earthquakes are occurring every year in a very narrow zone to drill a borehole of about 8 kilometers deep. And this we have started the preliminary work where we drilled 10 boreholes of a 1 to 1.5 kilometer and found which is the right location for the pilot borehole. And this place we will put first 4.5 kilometer deep borehole and put our instruments to record what exactly happens during the earthquake, how the physical properties of the earthquake change, what happens, whether there is any change in the heat flow, and several other measurements will be made. The sea level rise is another major area where we need to focus our attention, and you might have read in IPCC report that Indian Ocean, the sea rise is more than the global average. So, we wanted to investigate why it is happening such, and we are trying to understand the different aspect, that is whether how much is because of the thermal expansion, how much sea rise is because of the adding to the mass, that means melting of the glaciers and ice sheets, and how much it is because of the change in the ocean basin itself. Because when the large earthquake takes place like Sumatra earthquake in 9.1, the seabed about 1300 kilometers long, 150 kilometer wide was thrown up about 5 to 15 meter. So, this could make a large amount of change into the ocean basin, and the entire coast will get affected by cyclone, tsunami, sea level rise. So, we have now found out which are the most vulnerable areas. The red which you see are the most vulnerable areas. So, we can either protect them or put some kind of restrictions on investing very heavily in these regions. The ocean is another very important aspect, and there are a variety of services which we provide for the ocean. The one is the wave forecast, wave, current, the mixed layer depth, the sea surface temperature. This information is very critical for fishermen, it is also for the shipping industry, for navigation and many of such things. So, this given every day 6 hourly for the globe as a whole, for the Indian Ocean, for the Arabian Sea, for the Bay of Bengal, as well as right up to the individual ports. So, at different spatial scale, this information is provided. One of the most important service like farmers, we also provide to the fishermen, and here we gave them that where the fish is likely to be available and what is the environmental condition there. So, they can plan their fishing accordingly, and this is very successful program today. More than 90% of the fishermen use this information in our country, and this has led to very efficient fishing. They use less effort to collect the same amount of the fish, and this has resulted into contribution to national GDP 34,000 crore rupees. The polar is another major area which is very critical to understand the climate change, and we have two stations including a satellite receiving station to conduct the various experiments. The one experiment which we are doing is we are trying to find out how the ice sheet surface is changing, and in this we have created a 3D model, and this is monitored every year to find out the changes. We can measure change as small as 27 centimeter. So, it is quite good to find out the change, and whatever the change you can convert them into a water. So, that much water we have been adding to this. Also, we have been doing similar experiment in the Arctic. Now, the why Arctic and Antarctic both? Because you know that the sea ice in Arctic is reducing heavily, and in Antarctica it is increasing. Of course, not at the same level. So, we need to understand why you have a two separate system working, because though we say global warming, that means the entire earth is being warmed, we see the impact quite opposite to each other. Also, we are monitoring glaciers in Arctic. Now, Arctic is very critical for India because what happens in Arctic directly affects our monsoon. If there is any very cold climate in Arctic, we have seen in the past that the monsoon is weak. So, we need to understand how this changes in the Arctic is likely to affect our monsoon. So, that is why large amount of studies now being done in Arctic. Also, similarly, we monitor the glaciers in Himalaya right from the snout to its head, and this is being done in about 8 to 10 glaciers in the Himachal Pradesh, and this is we are doing for last 3 years, but we need to wait that before we make any definite statement that how the changes are occurring and what are the likely reasons for these changes. So, we will come back to that once our experiments are completed. The next major area is the ocean mineral resources. As you know that we depend today for our all energy needs on the ocean. All petroleum products come from the ocean by and large. We would be also depending on many more things on the ocean in the future. So, the first thing is we need to have the complete understanding about our continental shelf. So, large amount of survey has been done and it is continuing to understand what all we have in our continental shelf. Our current exclusive economic zone is about 2 million square kilometer. We are likely to add another 1.2 million square kilometer. So, our land area and the ocean area both are likely to be same. So, same amount of efforts we will need on the exploring the ocean what all it has. Now, one which we have been doing for last 15 years and now we have been able to identify what we call as the first test mining site. The map which you see is a test mining site which is a 6,000 meter below the sea. Now, you know that the pressure of water is very high. So, the kind of equipment which you need to even get the information has to be designed. So, this is what we call as a remotely operable vehicle which can go up to 6,000 meter, and it is something like a satellite. You can put sensors up to 150 kg and you can measure the temperature, you can measure the currents there or oxygen or whatever sensor you put, and this has been working extremely well. And we, along with the other instruments, we have now estimated that the total nodules, polymetallic nodules is 380 million metric tons, and the next level if required we can mine them. So, now our concentration is on developing the instruments for mining this kind of nodules. Also, in the sea there are certain areas there are large cracks and the magma comes out from those cracks, and these cracks also the water goes in and it comes out. Now this, when water comes out, it leaches the host rocks and brings some of the metals, which could be copper or iron, also gold, silver, platinum, many others. So this is the new experiment we have started in the central Indian Ocean to find out what kind of metals are available in this. This is the photograph which has been taken of the seabed by this instrument, and we have mapped surface of moon, we have mapped surface of Mars, but on the earth we have yet to map complete the surface of seabed. So this is one major area which we have been focusing to map the surface to find out how the topography is, what all available on the seabed. The gas hydrate is another major area which is nothing but the solid methane gas. Because of the pressure of the water, the methane which is at the seabed gets solidified, and this is the first level exploration we have done. Now we are trying to study that what are the signatures where we can say that the gas hydrate would be available. So this work is going on, and if we develop a suitable method to harness this energy, our energy problem can get practically resolved, because the huge resource of the gas hydrate is expected in our Krishna Godavari and Mahanadi basin. The water is another area which we are likely to get from the sea in future. Even today, if we are getting whatever fresh water is from the sea through a process by monsoon. Now what we have been trying to do is, we have tried to imitate the same process. So in this method, which is known as a low temperature thermal desalination, we take the surface water into a chamber which is in a vacuum. So at that temperature, which would be 26 to 28 degree, it starts boiling, and the vapor is taken into the another chamber where the water brought from the bottom about 800 meter is put, so that it cools, the vapor cools, and you get a fresh water. Now this plant is working in Kavaratti, Agatti and Minikoy for last several years. These are the small plants, and the beauty of these plants is can be managed by the local people. It does not require any expertise, and there is no environmental pollution like the reverse osmosis technology can give you. So because the water which we use is only 8%, so whatever the discharge back to the sea is as good as the sea water. Now we are trying to scale it up to 10 million liters a day, and we are working out the detailed design that how we can achieve this. The other important, some of the issues on the coast, the one many of you may be aware that the Gulf of Khambhat, there is a plan to generate a tidal energy and create a freshwater lake, and last several years the work was going on, but the actual information was not collected, because this is the one area where the tidal forces are very strong, about 7 to 8 knots, and it is very difficult for collecting the information. So we have now been able to collect the information, and we found only one result I will give you, that the all other studies said the depth is 11 meter, and now it turned out to be 38 meter. So the entire calculation about the volume of the water available has dramatically changed. So this is one example. The second example is the Pondicherry beach was completely eroded, and we have now given a solution that how you can restore the beach back. And this is the satellite images which shows that after the necessary measures are taken, you can see thin white line which has come up, which is the restoration of the breach. We are now going to have a permanent solution so that the complete beach is restored. And lastly, some of the climate change, like weather services, what we told, we will also provide a climate services for the different sectors like agriculture, water, forestry, health and many others. So this is what would be required in the future. To begin with, what we have done is some products like monthly mean temperature, total precipitation, standard precipitation index. So this kind of products are now routinely made available to all concerned, so that they know that whether there are any changes occurring in the monthly temperature or monthly lower temperature or a rainfall. So this kind of thing, which is extremely useful for the various sectors. Also, we have done a projections for the next up to 2095, what is likely to be a temperature, what is likely to be a rainfall every month wise, and this is a first cut projections. You can see that both the lines are not exactly matching. There is slight underestimation. So, we need to do little bit more work to make it very accurate, but these projections are now available from our own model, which is developed in India, to give the overall idea of this. Thank you.
Now, let us summarize what we have learned. We briefly learned about India's strength in the field of providing early warning of natural disasters like cyclone, earthquake, tsunami, and sea level rise. We also learned about our understanding in polar science and its linkage with climate change research, technological developments for ocean mineral exploration, and how these developments are beneficial to us. Thank you.